trout live lives subject to environmental conditions that fluctuate daily, seasonally, annually, and longer. Despite recorded annual survival rates of 24 to 45% across ages 0 to 4 years of 6 streams in the Minnesota Driftless, stream populations rarely congregate such that predation and competition become limiting factors. A 1983 Wisconsin DNR study observed that the average spring density of brook trout in the north branch of Beaver Creek was 63 per mile and 3.4 pounds per acre. By autumn, biomass increased to 332 per mile and 10.8 pounds per acre. Trout longer than 10 inches moved into the study area throughout the summer and fall, moving out during winter. A week ago, the previous pool had fewer adults and was prolific with fry. It's common for different year classes of fish to be ecologically segregated, which reduces competition for resources. Adults, from wintering habitat of the larger system, moved into the few pools, forcing this year's fry to relocate. Mass movements of fish are common, and on a regular basis. Aside from seasonal migratory behavior, daily migrations are typical for feeding and avoidance of predation. Advantages of migratory behavior include increased probability that larval stages find proper habitats, reduction in intraspecific competition among different age classes, and reduction in the probability of cannibalism. Migration as a means to separate different life stages of fish manifests regardless of environment where it occurs. River and lake-dwelling fishes find their way up small tributaries to make nests in their riffles. Small streams function as nurseries, where juvenile fish eventually make their way downstream to adult habitat. Every assemblage of stream fishes and their distribution is the result of unique interactions between the physical, chemical, biological, and zoogeographical. The thermal tolerance limit for brook trout is 75.6 degrees Fahrenheit. Though they can survive short spikes in excessive temperatures, such as those associated with surface runoff from heavy rainfall. Profoundly, gradient influences water velocity and number, size, and depth of pools. As gradient increases, diversity of habitat decreases, limiting the number of species present. Diversity of species tends to increase with the stream order. In first-order streams, the dominant fishes usually feed largely either on insects that drop into the water, as brook trout do, or detritus, like the fathead minnow. And downstream, pisciphores, represented by basses, and other specialists lurk. Severe floods or extreme drought reduce populations, sometimes completely eliminating fish from sections they'd be expected to otherwise occupy, while moderate fluctuations over a long period of time allow for those fishes from higher order streams to inhabit sections of the lower orders. Chemically, streams tend to be cleaner than lowland ponds. Flowing over a variety of substrates, streams tend to be well buffered and oxygen saturated. Streams of the Ozark uplands exemplify clean water with their high dissolved oxygen, high alkalinities, and low conductivities. Sewage lowers pH, contains heavy metals, sulfide, and other chemicals that limit fish habitation. Because the physical environment changes so frequently, interactions between organisms is too going to vary from hour to hour, day to day, season to season, and year to year. Predation is the most common cause of mortality for stream fishes. Competitive and symbiotic interactions as well contribute to distribution or concentration of fishes. Zoogeographical barriers prevent species from occupying habitat that would otherwise be suitable for them. St. Anthony Falls, for example, keeps fishes from accessing the upper Mississippi River. Groups of fish respond to interactions between various physical and chemical factors, and such species tend to occur together in particular environments, forming recognizable associations. These fish zones across geography tend to have much in common with each other, despite region, in terms of environmental makeup and fish morphology. This diagram generalizes the pre-dam distribution of native fishes of the Sacramento-San Joaquin drainage system of California. See how its fishes conform, though gradually, to zonation by environment. High gradient regions with their rocky bottoms and swift cold water, trout, sculpin, and dance dominate these environments. Warm water streams of the moderate gradients, the long middle sections of streams, typically host minnows, suckers, sunfish, darters, and catfishes. And the sluggish waters of the lower reaches of systems keep carp suckers, sunfish, shads, and basses. A working hypothesis postulates that brook trout evolved to take advantage of the Pleistocene's glacial melt. These char emerged sometime between 2.6 million to 11,700 years ago. Their anadromous cousins, salmon and rainbow trout, evolved 4 to 6 million years ago. How migratory behavior could have adapted to accommodate new flows across Midwestern streams, and preserved by their ancient cold water bubbling up from the Silurian bedrock.